So ionic compounds are formed between a metal, remember what we said, and a non-metal. In order to identify physically fast, is this an ionic or a molecular? What I always tell my students is have two fingers, one on each of them in one element. And then if the fingers are apart, then you are dealing with ionic compound. So a metal here and a non-metal above the stairs, then you are dealing with ionic compound. And if the two fingers are closed, then you are dealing with a molecular compound. What they are doing, or the two elements in an ionic compound, they are exchanging electrons. Exchanging, I think that I spelled it wrong. Changing electrons. What does it mean? The metals that have less electrons in the outer shell, because they are group 1, group 2, so they have 1, 2, and so on. Metals have the tendency to give that the electron that is in the outer shell easily, to have the outer shell completed with 8 electrons. So if, let's suppose that we take magnesium, even when you see it here, it's a +2, means that it has the tendency, so when we see the distribution of it, it's in the 12th place of the periodic table, meaning that we have the number of protons is equal to 12. And then in a neutral situation, those positive charges have to have the same number of negative charges, which means that we have 12 electrons in total for magnesium. And then being on the 3rd period of the periodic table means that we have 3 shells that the electrons are distributed. That electrons are distributed. Okay, so the distribution of those electrons happens like this. So if we have magnesium here as the nucleus, then on the 1st we have 2 electrons, on the 2nd we have 8 electrons, which means that we in total have 10. And then on the 3rd we have 2 electrons. So those 2 electrons that are in the outer shell, magnesium being a metal, have the tendency to give them away to someone, another element that likes those 2 electrons to complete the outer shell. By giving those 2 electrons away, what magnesium is doing, it's turning into an ion, and it's known as magnesium ion. Okay, it's turning into an ion, and it is transforming itself into a positively charged ion. So now what do we have is we have a magnesium 2+. The name, it's known as magnesium ion, and it is positively charged because the number of protons, the positive charges, is greater than the number of electrons, negative charges. Those positive ions in another name are known as the cation. Cat has pole. So you can say this is how you remember it. Now, if magnesium is on its own, then will stay as a positively charged. But if magnesium is introduced, let's say it's coming close to another element, let's say oxygen, oxygen that is on the second period and is on the eighth atomic number, means that what we have is the number of protons is equal to 8, and the number of electrons for oxygen is 8 as well, if it is a neutral one. But being on the second period means that we have two shells that the electrons are distributed. And the distribution of the oxygen is like this. On the first one, we have 2 electrons, and on the second one, we have 6 electrons, 6 electrons. 6 electrons. So this outer shell of the electron of the oxygen is not completed with 8, but known as the octet rule. So the oxygen would like to have those 2 electrons that magnesium has in order to complete it, to complete the outer shell with 8 electrons. And then what is doing by absorbing, by taking those 2 electrons, is turning into an ion. The ion, when you are on this case for oxygen, is called oxide. It's a negative one. Okay, so oxide, and then it is turning into a negatively charged ion. Because the number of electrons is higher than the number of protons. Now, with those 2 electrons, we have 10 electrons, and the number of protons is 8 still, because it doesn't change. And with a specific name, if cations are known as the positive ions, anions is known as the negative ions. So now what we have is we have 2 entities. One of it is magnesium 2 plus, positively charged, and on the other hand, what do we have is oxygen 2 minus. So we have 2 entities. One of it is positively charged, and the other one of it is negatively charged. Now, based on the general law of electricity, 2 opposite charges will attract each other. And this is what is happening into an ionic compound. We have the electrons are exchanged, making the atoms, the entities, positively charged and negatively charged. And since those 2 have opposite charges, they will attract. So you probably have heard when you were gone through Science 10 or Chemistry 20, something like this that the teachers have been doing. Drop and switch, and then find the lowest common denominator. So you will have here Mg2O2. Since this is the same, then the formula will be MgO, which in the IUPAC in the IUPAC rules, this is known as magnesium, because this is how it is named. Start with a metal, and then followed by non-metal, the root of non-metal, and then I add the suffix IDE. So this will be magnesium oxide, as the IUPAC name. However, what do? Is you find the lowest common multiple of the charges. So let's suppose that we have sodium, and that is with a charge of +1. And let's say, I don't know, oxygen, we have 2 minus. Then the lowest common multiple of 1 and 2 is 2. And then you say, what are you multiplying 2 by, or 1 by, sorry, 1 by, to give you 2? And you are multiplying 1 by 2. So then put that number as a lowercase, as a suffix. And then what are you multiplying 2 by to give you 2? By 1, and 1 is not written there. And the name of this will be sodium, because you start with the name of the metal, and then the root of the non-metal is oxyite, the I8. So ionic compounds are bonded together through the electrostatic force that exists between them. It's the electrostatic force that exists based on the general law of electricity, that opposite charges will attract each other. Since we have now two entities, that one is giving the electrons away, turning itself into a positively charged, and one is receiving those electrons away, turning them into a negatively charged entities, which we call ions. And if we want to be more specific, the positive ions, positively charged, are known as cations, and negatively charged is known as anions. And those two entities, that at the essence, they are positively charged and negatively charged, they attract each other, and they are formed into ionic compound.